Now with class 9, we'll explain trigonometry. We'll explain right angle trigonometry, non-right angle trigonometry, areas, area of sector, length of arc. We'll start with the non-right angle triangle. Let's draw a triangle first. This is my right angle triangle. This is a right angle triangle. The side always opposite to the 90 degrees angle is the hypotenuse. Let's call it C. And this side, let's label it A, and this one as B. First, to start with the Pythagoras theorem. Pythagoras theorem states that the hypotenuse squared is equal to side 1 squared plus side 2 squared, which is C squared is equal to A squared plus B squared. This is Pythagoras theorem. Now let's introduce trigonometric ratios. Let's say this angle is theta, and the side opposite to theta is considered to be the opposite, and this side, which is B, is the adjacent. Now the first trigonometric ratio is I'm having sine theta is equal to the opposite over hypotenuse, which is equal to A over C. This is my first ratio. The second one, I'm having cosine theta is equal to the adjacent over the hypotenuse, which is equal to B over C. And my third ratio is the tan. So I'm having tan theta equal to the opposite over adjacent, which is equal to the opposite is A over B. These are my three trigonometric ratios. These are so important. And it's important to know how we get the tan as a ratio between sine and cosine. Let's take opposite over hypotenuse divided by adjacent over the hypotenuse. So when we divide, we multiply by the reciprocal. So this value is equal to opposite over hypotenuse times hypotenuse over adjacent. The hypotenuse with the hypotenuse are cross out. So I'm having opposite over adjacent. The opposite over the adjacent is tan. And this value is the sine. And this one is cosine. So I can conclude that sine theta divided by cosine theta is equal to tan theta. And this conclusion is really important for us. Now, for non-right angle triangle, let's talk about non-right angled trigonometry. Non-right angled trig. Let's draw a triangle. We'll draw a triangle. This is my triangle. And this angle is A, this angle is B, this angle is C. The opposite side to angle C is small c, the opposite is small a, and we have small b. The first rule to know for non-right angle trigonometry is the sine rule. The sine rule states that sine angle A over side A is equal to sine angle B over side B and is equal to sine angle C over the side C. Or we can write it as side A over sine angle A is equal to side B over sine angle B and is equal to side C over sine angle C. This is my sine rule. I have another rule, which is the cosine rule. Let's draw our triangle. This is angle A, this is side A, and this is side B, and this is side C. We use the cosine rule when I know two sides and the angle between them and I want the opposite side, or when I know three sides and they want to find an angle inside the triangle. The cosine rule states that, this is my cosine rule. The cosine rule states that the side A squared is equal to B squared plus C squared minus 2 times B times side C times cosine the angle A. We can use it whether the unknown I have, depending on the question. These are the two rules for the non-right angle trigonometry. To continue with, let's figure out how to find the areas of a triangle. Let's say I'm having a triangle and I know the perpendicular height of the tip of the triangle from the base. This is my perpendicular height and this is my base. If I know the height and I know the base, simply I can find the area of the triangle, which is equal to half times the base times the perpendicular height. If I don't know the perpendicular height, let's take this case. Here I don't know the perpendicular height, but I know this angle theta, and I know side A, this side A, and this side B. I know two sides, and I know the angle between them. So now the area of the triangle is equal to half times side A times side B times sine the angle between them. This is my area. I hope it's clear how to find the area. Now, let's talk a little bit about sectors and arcs of circles. Let's draw this circle. This is a circle. We draw a radius. This is let's draw another radius. So now, this is my angle theta. And I need to find the area of this sector. So to find the area of sector, this theta is a ratio out of 360. So I have theta over 360 times the area of a whole circle, which is pi r squared. This is the area of the sector. This value is in degrees. If I want to find the values in radian measures, I have to change 360 into 2 pi, which is equal to theta over 2 pi times pi r squared. The pi cross out with this pi, so I have it as theta over 2 r squared. This value is in radian measures. This is the area of sector. To find the length of arc, let's draw the circle again. This angle is theta, and I want to know this arc, which is L. So now, length of arc. How can I find the length of arc? Is equal. First, I take theta as a ratio of 360 degrees, which is the full rotation inside the circle, times the circumference of the circle, which is 2 pi r. Also, this value is in degrees. To find it in radian measures, I need to have theta over 2 pi times 2 pi r. The 2 pi crosses out with the 2 pi, having a final value of theta r. This value is in radians. I hope it's clear how we can deal with right angle triangle. Non-right, the area of triangles, finding the area of sector and the length of arc. Now let's go to solve a question. Also, it's taken from the question bank. The following diagram shows triangle ABC. This is triangle ABC. AB is equal to 3 centimeters, BC is equal to 8 centimeters, and the angle ABC is pi over 3. Pi over 3, this angle is given in radian measures, because I have the pi over 3. Is not in rad, is in radian measure. So, part A show that AC is equal to 7 centimeters. This is the unknown. This is AC is the unknown. I need to find AC. Now, I'm having this side AB, I'm having this side BC, and I have the angle between them. And I want to find the opposite side, so I use cosine rule. Cosine rule, to use it now, I have AC squared is equal to AB squared, which is 3 squared, plus BC squared, which is 8 squared, minus 2 times 3 times 8 times the cosine of pi over 3. To find this value, we need to use our GDC. But first, we have to check that the GDC mode is on radian measures, not in degrees. Because I have my angle in radian. Started, this is on. First, I have to check if it's on rad measures. I go to mode. The third choice. You see here, the shaded part is radian. And the one to the right is degree, but I need the radian. So let's enter. I choose the radian. Now I go back and I want to find it. I have, this is 3 squared plus 8 squared minus 2 times 3 times 8 times cosine the pi over 3. To find the pi, I press second pi over 3. And I close bracket and I close another bracket because I already opened one here. So I have my value, which is 49. So AC squared is equal to 49. I have to take square root to both sides, so AC is equal to 7. This is my answer. AC is equal to 7. This is part A of the question. Let's see part B. Part B, the shape in the following diagram is formed by adding a semicircle with diameter AC to the triangle. We've added a semicircle. Find the exact perimeter of the shape. So the perimeter here, this is part B, is equal to this side plus this side plus this arc L, which is equal to 3 plus 8 plus L. Now, to find L, do we know AC? Yes, of course we do know AC. This is, if I want to draw a line, this is AC. And this angle here is 180, which is pi. The side AC is 7. So the half of AC is 3.5. So my radius here is equal to 3.5 and my angle is pi. So now L is equal to pi, this is in rad. We can go to the area of sector. The length of arc. We have it pi times r in rad. We have it pi times r. So the length of arc is equal theta times r. It's a theta times r. Yeah, which is pi. So my length of arc here is equal to pi times 3.5. So now the exact perimeter is equal 3 plus 8, which is 11, plus 3.5 pi. The question wants, this is so essential, the exact value. So the exact value, I leave it in terms of pi. So now the parameter, this is my final answer. Practice well, because this trigonometry is really essential to understand our coming topics.